It's always the same, as always, sad and tongue-tied. It's got a memory and refrain. I'm afraid, you're afraid, and we die and we live and we're born again. Turn me inside out, can I say? Up and around we go, 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 up and around we go. Break down, 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 Hello? Oh, hi. Now that sounds right. Front man, write love songs. You say I like that. Hold on, I'm calling back to the bowl, and we'll dazzle them all. Hold on, hold on, I'm calling back to the bowl, and we'll dazzle them all. Hold on. Pick up the phone, and I want to go, and I want to go home now. Pick up the phone, and I want to go home now. Up and around we go, 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 up and around we go now. Lady, come on, set me free. Come on. Sentimental, heartbreaking, everything's my fault. Sentimental, heartbreaking, everything's my fault. Hold on, I'm calling back to the bowl, and we'll dazzle them all. Hold on, I'm calling back to the bowl, and we'll dazzle them all. Hold on, I'm calling back to the bowl, and we'll dazzle them all. Hold on, I'm calling back to the bowl, and we'll dazzle them all. Hold on, I'm calling back to the bowl, and we'll dazzle them all. Hold on, I'm calling back to the bowl, and we'll dazzle them all. Hold on. Na na na.
No, you can't do the song again. Okay, one sec. Hi, everybody. That's an old song actually from like a decade ago, but somehow it got stuck in my head again recently. I've been kind of obsessed with it again. But hi everybody, how's it going? We're all here. Everything's done. I see a person. Cool. I got one face. I'll enjoy that one face for the moment. Oh, more. Sweet. Yeah. So today I'm just gonna wrap up. I have some pre-canned stuff to say. Yeah, we'll chat here and there. Everything's over except for the final. You know, you got the projects in. You guys went kind of all out on these projects, some of you. I will be doing a Josh Hug Reacts to 61B Build Your Own World. Build Your Own World. I gotta click that link. What is this? Oh yes, that, right. Anyway, so I am going to be doing a 61B Reacts thing where I'm going to react to some projects, and yeah, hopefully it'll be fun. Details to be announced. So let me open up some slides, because what college lecture would be complete without slides to look at? Here we go. So yeah, in terms of announcements, you know, basically from now until the final, try and study a little each day as opposed to all at once later. I mean, take a break too, but you know, final exam is comprehensive. It'll skew towards the more recent topics than the older ones, but the whole thing technically. I'd recommend, if you're somebody who's feeling a little behind, just do all the C-level guide problems, like all of them. And if you do that, you'll have the basic, you know, it'll be a check for you that you know all the basics. Same deal with the guide or the check-in exercises too. I would recommend, I've said this in other contexts, but I'll say it again here, which is that the way I learn best is to work with other people. So once I know the basic content, it's all about working on a really hard problem, getting totally stuck, beating my head against the wall, trying again, and then discussing like the struggles that I had as I worked through the problem, because that's where I'm going to identify the holes in my knowledge or the like cool things that I know where I can share with other people. So I will just repeat an anecdote you may have literally heard verbatim before, but I think it's a good one. It's the hardest class I ever took was graduate probability and statistics. Class was so hard. And so we would, a group of people and I, like 5 or 6, would all do the homework individually, maybe finish, maybe not. And then we would all go somewhere. In your case, it's harder since we're online. But we would go up on a whiteboard and write our solutions and explain how we were thinking about the problem. And people would interrupt as we went to say like, oh, you know, there's actually a way better way of doing that. Like if you take advantage of the fact that heaps are always, you know, whatever, like heap ordered, then you don't have to do all that extra stuff. Or someone might say, oh, I didn't realize that. You can just bottom up sync nodes and then make something a heap. And that's a way to share knowledge and basically fill in gaps by, you know, putting yourself in battle together, so to speak. So anyway, that's my main tip. That's the thing that I think helps more than anything else to get better at this stuff. Yeah, once you're all caught up. Okay, so let's talk a little bit about 61B. I already did a lecture, if you missed it, where I reflected on the structure of 61B itself. That is posted. I don't know if the video is up though, now I think about it. Okay, we should fix that. But this lecture here is the longer version of what I'm gonna do in part of this lecture, where this previous lecture like picks apart how this software engineering course was engineered. And you know, it's a lot of thoughts. So if you're curious about like my deep thoughts about why get lit this way versus that way or whatever else, and the discussion we had, that's a lecture for it. But I am going to touch on some a little bit. So first I'm going to say everything we did this semester in 12 minutes or less, and then talk about the future, yours and 61B's. So 14 weeks ago, it's kind of hard to imagine this, but we were at this point where we were doing Hello World, and you went from this Hello World thing to building Gitlet, and then finally, well, your own world, I suppose. And you know, that's a pretty tremendous thing, right? If you think like, what did I do in college, right? And in some sense, in a semester, you go from this to building something quite large. And I think that's, you know, an amazing thing and something I'm happy to, you know, work with you on. Now, more specifically, there are a bunch of things we learned. I'm not going to read all the bullets because nothing could be more boring. But there were a lot of things we learned about programming languages in general. We talked about the idea of organizing around objects as one philosophy. And in object-oriented programming, we saw these two different types of inheritance. We learned about typing, static and dynamic typing. I'm a big fan of languages which feature static typing, but you know, Python is a dynamically typed language. We talked about how to do generics in Java. We talked about my personal model of how memory works. And it's a little different than you might see elsewhere, but I think it's more intuitive. And when you get to 61C, you'll get a more realistic model if you take that class. We learned about Java, of course. We saw a little bit about how integers are represented. And then, as with any programming course, we picked up some idioms. And an idiom is just basically the usual way that people program in a language. We talked about some data structures. And this is where you're going to hit a lot of job interview questions one day. Not about Java specifically, but in Java, those data structures exist in a couple of different ways. One is the interfaces, like java.util.collection, and all of its subtypes, like map, set, list. Those are things that you now know how to use. And whether you're programming in Java or some totally other language in the future, you now know that things exist like priority queues or maps. Well, you should have already known maps from 61A, but you know that these data structures are out there and what they're useful for, and now a little bit more about ways that they can be limited. So for example, in Python, you knew about dictionaries, aka maps, but now if I tell you that the Python map is based on a hash map, you can understand why it is that if you iterate over the keys of a map in Python, they don't come out in sorted order. And it's because ultimately it's a hash table, and it doesn't maintain that sorted order anywhere. We also talked about our own types of collections and these interfaces like map61b and dec. These don't extend collection because, of course, they're not real, but we saw how we can define our own thing, just like what Java has. And then we saw a bunch of different implementations of each of these, like how you can use an array dec to implement dec or anything else like that. We talked about asymptotics. We talked about big O, big omega briefly in a discussion section, and big theta notation. Tilde notation you might have seen in some old exams, so I'm including it here. But these are basically all very closely related ideas. And you got to learn about how I'm picky about theta and how I feel like big O is somewhat abused, but it's okay. We talked about worst case versus average case versus best case. And we saw an example of why average case is useful. For example, quicksort. The average case is what we care about, even though the worst case is n squared. Now, we didn't do detailed analyses of these in a way that you might in like a 170 type course, but you'll get there. We talked about how to look at the runtime of code through inspection. It's a very hard thing to do, and in fact, is basically CS theory for open, like for any, you could write arbitrarily weird programs, and they will have arbitrarily weird runtime analyses. And we saw a somewhat subtle point, which is that multiplicative resizing, whenever we're trying to manipulate lists or like a deck-like data structure, that it's important that you double the size of your lists rather than adding one each time, or 100, or any fixed constant. Okay. We have this whole diagram. It's a ton of abstract data types and all the different ways we talked about maybe implementing them. And so in a year or so, when you're trying to remember what you learned in this class, this might be a good thing to go back at and look at. Say, oh, okay. And so the ability to see that for any particular data structure goal, like I want to build a set, there's all of these different ways of building these data structures. That's an important thing, right? It just shows you there's a divergent way of thinking about the same problem. And in a sense, what this class is the very earliest and most important computer science problems, like really studying them and understanding all the different solutions, because they act as sort of canonical examples of CS problems. They're elemental problems. And when you go to data structure or when you go to job interviews, you'll be asked about them because it is, while it isn't that important to know how a hash table works in your daily life, it is such an old and well-known problem that having them, when someone's interviewing you, having the ability to watch you work your way through these problems in a context that are all mutually familiar helps them understand how you'll solve new problems, like the ones you did on Gitlet and Build Your Own World. We talked about the differences between arrays and linked data structures. So array-based data structures, you can grab stuff out of the middle. Linked data structures, you need to scan through a bunch of links. So we saw there's different varieties of these. So array-based data structures, of course, we had the array dec, but then also a hash set or a hash map. Those are basically array data structures where we have an array of buckets, and then the buckets themselves are some kind of data structure. They're actually also a map. And then we have the linked data structures. So we have the list ones, we have the tree-shaped ones, which were hierarchical, and they allow us to organize information hierarchically and also get something bushier. Like a list is not bushy, right? It's stringy. With trees, we can get a nice bushy structure, which makes searching through that structure efficient, and also just makes it nicer to look at if you're trying to, say, visualize data. And we also saw graphs, which are the next level out, which is the generalization of a tree. And we talked about some of the trade-offs, which I mentioned earlier, being able to access things in the middle, and linked data structures can be more natural for many circumstances. terms of graph problems, we talked about a bunch of different problems, like how would you find a topological sort of a graph? Now, don't panic if you don't remember that term, because it was in one of the optional lectures. But we saw that, okay, this problem, what you're seeking is a vertex ordering, and one way you can get it is some DFS traversals. Maybe something a little closer to home, something you remember a little better is, let's say I want to know if we have multiple target shortest paths. Like I want to know, how do I get from Berkeley to everywhere? Then I want to try and find, I guess I should talk about this one because I'm talking about weight. So if I want to know the shortest distance from Berkeley to everywhere along roads, then the thing I'm looking for is the shortest paths tree. And we saw two different ways we could do this, Dijkstra's and this directed acyclic graph shortest paths tree. And I think this is also in one of the optional lectures. So all of these summaries, by the way, include all the optional lecture stuff, so don't panic if some of the terms seem unfamiliar. We saw an interesting comparison between data structures and sorting algorithms. So we spent a little time also talking about sorting, again, because it's a really important classic problem that you will never need to solve yourself, because guess what? People wrote sorting libraries 30 years ago. But we saw there were some surprising and deep connections. So for example, our comparison-based sorts were analogous to something like our, let me move my window here. So these tree-based sorts here, they're analogous in some sense to comparison-based sorts because you have to do comparisons to find the answer. We saw hashing-based sets and maps. In a way, those are kind of similar to integer sorting or counting sorting. And we saw tries, and TSTs are an optional topic, by the way, but TSTs are just a variant of a trie. But tries are analogous to radix sorting. So it's kind of a cool, neat connection. And then even among the sorting algorithms, they have their own connections, like selection sort. If you use a heap, well, then you really have heap sort. If you have insertion sort, well, if you insert it into a binary search tree, we talked about in the quicksort lecture how that's equivalent to partition sort. And by the way, partition sort is just a more descriptive name of quicksort. Okay. And then lastly, I guess, what do we have? Oh, we saw radix sorting algorithms have this neat connection to counting sorts, which is that you actually use counting sorts as a subroutine. That is, to do an LSD sort, you run counting sort on the least digit, the next digit, the next digit, and so forth. Okay. So hey, connections. We saw some fun, weird topics, which you may not have watched. I think in a coronavirus semester, it is. I think that the viewership for these is probably on the low side, especially with Project 3.2. But there was a neat lecture about compression and kind of mind-bendy, perhaps overselling the magic of CS theory lecture, where we talked about complexity and P equals NP. All right. Now, along the whole way, there was an underlying thread, which is a strong piece of the identity of the Berkeley data structures course that wasn't present, for example, when I was at Princeton, which is it really talks a lot about programming more, right? So we talked about, of course, Java syntax and various idioms, like ways to do things like creating an iterable or a comparator. We also talked about things like JUnit testing. Now, when I was at Princeton, they didn't do any JUnit testing. There wasn't much testing of your own code. And try as I have attempted to convince my old colleagues, please add JUnit testing to Coast 226. I haven't done it. Mining the web for code. Again, when you're trying to implement Project 3 or Project 2 in this class, you really got to go digging online to find the references for how to do various things. And I think it's a really important skill. Some would argue that the main skill of a software developer is being able to copy and paste things from Stack Overflow and then bend them to your will. So you've gotten hopefully a chance to kind of do something like that. We talked about debugging, and we're getting close with 6D1B to teaching debugging right. We're still not quite there, but I was pleased to see how many of you worked through the kind of annoying Gitlet debugging tool and hopefully found that useful. And you've gotten a sense of how complicated debugging can be. And sometimes you have to build up a whole infrastructure of complicated tools to make it work. In our software engineering lectures, we talked about avoiding various ways in which complexity arises. And if there's any lecture that I want you to rewatch in a year or so, whenever you've had a little more programming experience under your belt, it would be Software Engineering 2, because I think it's, I mean, I had such a fun time putting that lecture together and learned a lot. So I think you will, again, someday, maybe. Talking about using some real world tools, and hopefully you can take those forward and actually use them in the future. Certainly you'll use Git a lot, but if you work in a Java shop, it's quite likely you'll be using IntelliJ, but maybe also Visual Studio Code seems to be pretty popular. And then, of course, we saw how picking data structures is really important. And you got a sense of that in Project 3 and also Project 2. Though, honestly, in Project 2 was, make a lot of maps. Let's see. All right. So that's Java. We did it in, I think, 13 minutes. No, actually, no, we beat it. Sweet. Okay, good. Okay. All right. So let's talk about the future a little. I would like to ask you some, or like answer a couple questions. Okay. And I'm going to talk about my own life experience a little. So there's two interesting questions you may have about yourself, wherever you are, whether you're, a freshman, sophomore, senior, whatever, grad student, something else. So you might ask yourself, well, what am I capable of achieving in life, and what should I be doing with my life? And I think these questions come front and center, especially when you're someone at a place like Berkeley. You know that you're someone special, like at least your position in life is special because there's only so many Berkeley students and you've somehow found yourself here. But you're also surrounded by all these brilliant people, and it could be stressful. Like you can't help but compare yourself wherever you are. Okay? So I want to talk a little bit about Josh Hugg, me, that is. This is my high school report card, and I would say that like I was an okay high school student, but kind of bad in some ways. Like I had a couple semesters which were fine, but like I was taking honors math and I was getting like 90 and 85. Like this it's not that great. And it's not bad. I'm not gonna say they're bad grades, but they weren't great. In 10th grade though, I definitely like kind of hit a rough patch where I just wasn't into school. I didn't do that well. In algebra 2, I got a 77, which is a grade that would probably displease your parents. In fact, I will confess my own quite unethical move, which was there was a time when I modified my printed report card, printed on dot matrix paper using an eraser, kind of adjusting the grade a little to avoid getting busted, though I did get busted. Don't do that, kids. Yeah, it did okay. I did okay. But, I would not look at this report card if I was looking at a 10th grader and think, okay, yeah, this guy's going to go run this class at Berkeley, right? And so I mention all this because I don't want you to feel defined by the arbitrary hoops that we're having you jump through, right? Another hoop that you, of course, have to jump through is our exams. So this is the midterm 1 coding exam section this time around. And it is, I really want to talk just for a moment to the people in this range who are really who are passionate about this and are really trying hard. And I think a lot of people in this end, there's just extrinsic features of your life that are making 61 be really, really, really hard for you, right? Like you're working full time, also while taking a full course load or whatever, and you didn't really understand 61A. But a lot of folks here are really pushing hard. I don't want you to feel like I cannot do this, right? Like it is the case that you did not kick ass on 61B exams, but I really, really feel like you can get really good at this just by being here. And I think the thing is, I mean, if you ever look at like Olympic athletes who are running, like the difference is like, less than a second of these people doing sprints or whatever. But they're all really close. And the thing is, like, if you are like a regular person running against those people who've been training their whole life to be sprinting, like, it's all gonna look kind of close. You're like, oh, look at all these people like way up here, in this like bin of people really killing it. What am I doing over here? Just that you're not there yet, right? But I don't want you to feel like that there's some intrinsic attribute to your brain that means you cannot be a software engineer or you cannot apply these skills, because I think almost every single person at Berkeley could get very, very good at this material. To some people, it takes a little more time. I'd be curious to know your answer to this question. But do I want to actually do the poll? Because I didn't actually create the poll beforehand. Well, I'm going to try. I'm going to click the poll button and I'm going to push the add question button, and it's not going to work. Okay, hold on. I got to try and hack this thing. I really want to do it. Oh, okay. I don't know if you can see what I'm doing. I'm trying to grab the URL before it. Okay. No. All right. Bummer. Okay. I did think about doing this poll beforehand, but I was having such a fun time at my TA meeting that I didn't actually do it. Okay, here we go. Give me 1 second to awkwardly, clumsily try and create this poll. Okay, here we go. All right, I did it. All right, so let me create this poll, and I will share my whole screen so you can watch it happening. Okay. All right. I want to know what you guys think on this question, just to get a sense of your Carol Dweck would call it like the growth fixed mindset thing, but all right. Okay, that poll, you can see it coming. You got a lot of time to think about your answer in the meantime. It's added. Okay, and now I'd like to ask the question. Where'd my question go? No, why are you doing this? Okay, hold on. I'm gonna look at the chat so I can enjoy some fun. Just click SSO, is that the secret? All right, if that fixes it, then I'm gonna be embarrassed. All right, we're ready? Let's all log in together. Okay, that's me. Send me a push. Given enough time, can anyone get a poll working? I think so. Invalid meeting ID. Well, that's not good. What? Zoom. Oh, well, that was fun. You know what? We're going to do it anyway. We're going to work around the technology. Yeah. I am going to create a Google form, and I'm going to put it in the chat. What's straw poll? Here we go. No, I want to do it now. Straw poll. Okay, here we go. Straw poll. Okay. This is fun. All right. Okay. You guys, it seemed like such a good idea. All right, this better work. Otherwise, I'm holding whoever suggested it accountable. Share. All right, there you go. Okay, go to that thing. I want the answers. Okay, I'm gonna click the results button soon. Actually, I'm gonna stop sharing for a moment though, so I don't spoil it. Okay. I need more answers, and there's a couple more. This is interesting. All right. This is a very different distribution than I remember getting in real life. Okay. All right, here's what you guys think. So just in case you're kind of curious where you are. Okay, so we got agree and strongly agree are the plurality. Interesting. All right. Great. All right, I agree. So, you know, as you might have guessed, I think the answer to this is yes. Was that worth all that time? I don't know. And so, you know, part of it, I did this interesting experiment a while ago where I, let's see, here we go. I want to go to this slide. So in spring 16, back when I had a little flexibility, people were pretty stressed out about declaring then as they are now. But there was a loophole in the system, which was if you fail 61A or B or 70, then you can retake it and your new grade will replace it. So I kept getting all these students who were would try and like bomb the final if they thought they were going to go out badly and weren't going to be able to declare. So I just said, hey, you know what? If you want to fail on purpose, you can give me a conditional grade on the final survey. And it said, like, if I get less than a C, fail me. And I did it. And so the students who came back, actually, there were about 40 students who intentionally failed themselves, something like that. They came back and took 61B a second time. And on average, students did almost 2.5 to almost 3 letter grades higher the second time, like than what they were on track. Sorry, if you were in the middle of the B range, and what I mean by that is, I'm leaving out a detail here, which is that 61A grade correlates extremely closely with 61B grade. Like almost nobody is 2 bins above their 61A grade. But the people that did 61B twice, they were way ahead of where they were in 61A. And so that says to me, there is some sort of preparation for 61B that helps you do much better. That may just be 61B again. So the bottom line is, like, I'm really talking to my C+ to A- or B+ students who see themselves surrounded by just incredible achievement and think like, I cannot keep up. I really just think you need a little more time and you'll be doing well. Okay. So anyway, hope that's helpful. But yeah. Someone asked, why not change 61B though? I mean, I would like to change 61B in the long term. I'd really like to have a 2-semester option. I think it would be the right thing to do, but I haven't been able to do it. Too many moving parts. Okay, so that's what you're capable of achieving. I think pretty much everybody here can be really good at whatever. And something I've learned, I guess not on the slide, but something I've learned is that, now that I'm around people who run the world, not like, the president or whatever, but I don't know, like kind of fancy people here and there, it's just striking to me how much, us in our late 30s, 40s, I guess maybe 50s, that it's like they were all you not that long ago. And while they're maybe a lot better at certain things, just the really wicked, difficult problems of society, like how do you balance the UC budget or whatever, or like how do you run an effective organization and keep your team happy and whatever else, like these questions are so hard and nobody is good at them. Almost nobody, right? It's like surprising how it kind of feels like the people in charge, they aren't that much better at running the world than you might be, especially whenever you have a decade more of experience in life. Okay, so your future, I'd say, is pretty wide open at this point. So then the other question is, what should you do with your life? Well, I'm just going to give you a couple thoughts, because you can do whatever you want, of course. Like I'm a big believer in autonomy, and I have a lot of pretty like sharp, strong opinions about various things, but it doesn't bother me when people deeply disagree. I mean, like for example, I'm a vegetarian. I have been since I'm 18 for like pretty strict ethical reasons, but I mean, I don't really judge anybody else because it's just some arbitrary conclusion I came to, right? Whatever, right? That kind of thing. So I don't want to judge you if you're thinking like, I want to be an iBanker and make a bunch of money, right? It's hard for me to tell people how to live their life, but I do want to say like some perspective I have, right? I think that you will be in high demand by like everybody once you have all the skills that you've picked up from this class and what comes to follow and whatever else you're learning right now. And those skills will allow you to affect the world possibly profoundly. And I don't think that any generation of CS students or CS adjacent students, data scientists, or scientists or social scientists or whatever who have CS skills, all of you are very aware of what companies like say Facebook or Google or Twitter or Microsoft or Amazon like, and the way that they can shape the world. Like when I was in college, it was kind of a pipe dream. Like let's build an internet, it'll be cool. Like that's kind of was the vibe. But now you guys know what can happen, and so I just want you to be aware that the skills you have are just profoundly powerful. And so this is just going to keep happening for the rest of your life. The world's just going to keep getting pushed in all kinds of crazy directions, and you're going to be part of that. And so how you decide to use your skills is up to you, right? Like if you're working on, I don't know, let me not play the sound here.
Autonomous intersection.
But this is just an example of like a UT project where showing like what an intersection could look like with fully autonomous cars, which is like kind of terrifying to imagine, but could happen. Like that's a thing you could work on. It's not impossible. I wouldn't be too shocked if I saw streets like that in 100 years, let's say. I don't know, it could be way earlier. You could work on Candy Crush. And again, I'm not saying that that's a bad thing to do, like to build games that are like kind of fun and quirky and people can play them whenever they're like sick in bed, right? Like that's fine too. But it's up to you. You could do both of these things. And in fact, probably one of the easiest things to do straight out of college is go work for a deep-pocketed company where you can pick up a lot more skills and learn what's possible, right? That's totally fine. But what I would ask is just like, my general request is these superpowers with which we are imbuing you, do you try and use them in a way that at the end of your life, you can say, I think it was a net positive for the lives of my fellow humans, okay? Now, I mean, I'm not saying, as I note here, that you need to say, okay, I'm only going to strictly go work like at a minimum possible wage, working for, some charity, providing services for people that are downtrodden. Like that's great, but this is not compatible with the way that humans are in general, in my opinion. Like I think that we all seek some sense of progression in our own lives and our own comfort. And as you have a family, of course, you will realize that like life is expensive and fragile and difficult. And so, impoverishing yourself is quite a dangerous thing to do. But yeah, keep in mind that the work you do will quite profoundly affect the world. And so if you want to talk about this kind of stuff more, I'll be teaching CS 195 next year. I will never be preachy because it's just anathema to my way of being. I have a very like anarchist heart, but I do like tackling the difficult problems and talking about them and hearing from people. So 195 will exist, next year. I'm doing it both semesters. In the fall, I'm co-teaching it with John De Niro. In the spring, I think I'm solo teaching it, but someone might join me. There may be an honors version too. I don't know yet. Depends on the budget. Okay. Now I've already kind of done Ask Me Anything to death, but I'm going to do it again just for a short time. I will, of course, I'm happy to continue answering such questions. We did like a whole day of this basically. But if anyone has any questions about anything, I think it feels good to get, I don't know, 8 minutes in or so. I'll tell you about CS195 very briefly. So CS195, assuming I'm still sharing my screen appropriately. Yeah, so if you're interested in the honors version, you can email me. It'll probably get lost, but email me and John. We just don't know if it exists yet. But I'm going to go to my most recent version because this is not mine. All right, so this is the last time I taught it last fall. We talked about free speech, privacy. Megan Phelps Roper, who is a person I vaguely know, who I came in. This is a very interesting story. She's a convert from a very cruel and well-known cult known as the Westboro Baptist Church, and is no longer part of it. Anyway, and all this sort of stuff. So yeah, it's like a pretty lightweight class. And if you're in engineering, it is the lowest workload way to get your ethics requirement taken care of. Yeah, cool. Okay, let's see. Have I been to Kazakhstan? No, I haven't. I'd like to go. Sounds fun. I have been never really to Central Asia at all. It's on my list, but never been. My wife comes from a Russian Tatar family. Not quite Central Asia, but it's getting there. Yeah. Oh, so the thing is, I'm not really an anarchist in the Peter, what's his, the Conquest of Bread guy, but there is some resonant Kropotkin, right? Anyway, this notion of having no hierarchy really resonates with me. I don't like authority. I don't like the hierarchy of our society, and I don't like that. Like, I feel like human dignity should be like the first and foremost value at all times, and it's just not. And so I feel like my only concern, I haven't read enough, but my fear is that anarchism is too optimistic about human nature. But anyway, I don't know enough. But I have a lot of friends that are like, 1 foot in that world. Let's see. Oh, right. So my Kazakhstan thing was totally a lie. I just picked some random place because I was filling my LinkedIn profile with lies. Would I recommend graduate school? Sure, for the right person. Come talk to me at office hours sometime. I would not go to grad school just to have a degree, but there's many reasons you could do it. Do I think the world is more forgiving for mistakes earlier than now? Yeah, definitely. Though I don't think it's infeasible that we'll see it swing back the other way. I feel like, I should say, I guess you might be talking about Megan Phelps Roper. She was posting on Twitter some pretty virulent stuff that she's never deleted. There's a certain poise that you can exhibit where I think you can transcend your background. Yeah, Kropotkin, that's the one. Can any technological advance be weaponized if you're creative enough? Sure enough, I bet so. Let's see. Honors 195 should exist. I just don't know that it might disappear. We can't get the TA. Yeah. Let's see. Why is Java becoming less popular? It is actually a good language. I think it is a good language. It is a little clumsy in some ways because of when it was designed and the way they had to backport some features in. I think it'll be around a while. What's funny is that Java itself might decay, but the underlying Java virtual machine will probably always exist. So, I wouldn't be upset if, for example, Kotlin completely replaced Java. I think of Kotlin as a strictly better Java. But yeah, I would teach this class in Kotlin if Kotlin was more popular, but I want you to have, Java's still the most popular language except for like the C++ family. And I don't want to teach this class in those languages. It just would be unpleasant. It's like a little too much detail revealed. I'd rather do that in 61C. Am I a wrestler? No. But I did have a friend who really liked doing Brazilian Jiu-Jitsu and when I was in college. But I'm 5'4" and I weigh 120 pounds. So I wouldn't be very good in most situations in battle. But it's fun. Oh, right. When we can meet. Good question. I forgot about that. So I guess later today. Oh, right. Let's see. Give an opinion on people trying to choose between data science and CS. No. I think there's 2 considerations. One, which gives you the flexibility to take the classes that seem most interesting to you, because either of them will give you the technical skills you need to do like whatever thing you want to do. The second is, do you think that having CS is necessary because it'll help you really want to do software engineering and you really want to work at Google or whatever, and you're worried that you need that extra fancy major. But we don't really know. Data science is new. Not sure. I heard a sound. Do I have Minecraft? I mean, I played it. Yeah. I like it. It's cool. It's fun. And it's a pretty good thing. I went to the Minecraft graduation last year. Yeah.
Oh, yeah, Berkeley.
Sure.
I heard some sound again. Someone's unmuted who didn't mean to be, I think. Watch Avengers Age of Ultron and discuss the ethics of creating Ultron and Vision. Okay, that's H195. The difference between 195 and the honors version is a weekly section that will be run by a TA and some more homework. Favorite restaurant in Berkeley? It used to be China Village on Solano, but they really slipped. I don't know what happened. It's a bummer. But yeah. Now, good question. Zachary's is kind of a boring answer, but they are really good. I'm just thinking through what is specifically in Berkeley that's super good. There's a lot of places that I like. Oh, actually, I think at this point it's by MTI. Yeah, MTI is my favorite. IRL meeting thing has not yet happened. People have not been chosen. Do I use terminal editors? Yes, I use Vim when I am editing something on a remote server, and it's too annoying to set up a remote text editor. I think Vim's great. Yeah, to be clear, that favorite restaurant in Berkeley is MTI, but it used to be China Village. Let's see, boba. I've only had it once. Too old. 195 growing. I guess it could. How many seats are in it now? Why is there such high demand? We only had 200 last time and it was fine. Okay. Sorry. It could, but I want to have it in person. There's only one room we can have, and that room only allows. Oh wait, no matter what room we pick, we can only have 199 people. So maybe we could make it bigger. What do I think about 61 seat? It's really cool to see the first time, but I ultimately find the content a little boring. The Berkeley version, I think, is way too hard. Too many deadlines, but I don't know when they're taking it. All right, I got one more room for one more. I have no idea about phase 1, phase 2, and how it works. And will 195 be offered for the foreseeable future? Yes, indeed. And I don't know what Blazeball, is that smoking weed and playing baseball? If so, then I've just figured it out, but I hadn't heard of it before. If it's something else, then no. Played DDR recently? No, but I really should. It's a fun game. We're running out of hard problems to solve, and they're tending towards impossible ones. That's a very interesting question. My gut feeling is yes, unfortunately, but we'll see. I mean, I think we're not at the impossible. It just takes much longer to get there. Favorite book? Probably Black Swan Green by David Mitchell. It's a book about a 12-year-old living in a village. It's great. David Mitchell is a very good author. I was also a fan when I was your age of White Noise by Don DeLillo. That book still gives me the heebie-jeebies. Yeah, anyway. Okay, I really gotta stop. But happy to do this, whatever. Like, I'm gonna do, actually it's funny, when I do these random Twitch streams, people, like a lot of people showed up and enjoyed them. So maybe I could just keep doing these AMAs in the middle of Twitch streaming, whatever. All right. Berkeley CS professor who I'm closest to, probably John Denira, I'd say. Yeah, I mean, I know a lot of people pretty well, but John and I are pretty simpatico in a lot of ways. I'm gonna do one more. Favorite country I visited, have I been to Vietnam? I've never been to Vietnam, I'd like to go. Favorite country. It's always complicated because it's wrapped up in the specific experience you had. Cambodia, actually, though, I gotta say, is Cambodia. Cambodia was, sorry, my Vietnamese asker. One day I'll go to Vietnam, but Cambodia was a special place where the entire country had gone through a collective and unfathomable trauma. And it was kind of interesting to be there kind of in the, the shadow of it, and have everybody like really coming back from it, I mean, a generation later, but it's still there. It was a place where I really felt like welcome as a random person from outside. It's like even though people knew I was some random white guy, so probably had a bunch of money, which I didn't, but compared to them, I did. I never felt like I was a target for like some source of money. Like I really felt like, I don't know, there was a sort of friendliness that was in almost everybody I met. I don't know why, but yeah. Anyway, Cambodia. All right. Oh yeah, I'll go to Twitch again. All right. Anybody got questions? I gotta stop so I can finish. But yeah, I will make a list of all the places I've been sometime and talk about each of them. All right, cool. Okay, I want to close out by reflecting on the course, so I can tell you what we did in the past and what we're going to do in the future, and you could be primed to give us good feedback. So what was new this spring? Well, these are new things since last fall. The first is we changed up our policy a little bit. We did 6 slip days. Usually it was 3 way back in the day. But we did 6 slip days, but now a flexible policy if people came to us with life crises. So last semester we had 15 slip days in this amnesty thing, and it caused some headaches for the logistics. So this time we just made it so that it felt like you had a lot, but if you ran out, you can come talk to us. All right. We did 2048 instead of n-body in order to have a richer algorithmic challenge. That seemed pretty good. We had Gitlet instead of bare maps. Verdict's still out on this. My personal opinion, Gitlet's too big. I don't like it. It stresses me out, but a lot of people liked it. We'll see. I'll make data-driven decisions despite my own anti-Gitlet bias. We did a much more widespread use of the Snaps plugin, and we also did some pretty aggressive data analysis of the data we got. Thank you. Lecture 34 covers that. We did some live coding. Oh, so in lecture 34, if you didn't know, I actually went through the Snaps data for Gitlet and talked about the average amount of time it took people to take it, distributions of that time, and also showed the overall workload over the course of the semester. So it's pretty cool. Go look at lecture 34 if you haven't yet. We did live coding at the, that's not new. Why is that there? That's, Okay. We did 2 conceptual homeworks instead of 1, and we did asynchronous checkoffs for project 3. So, some changes, but the big changes were to the projects, not less in the way the class was taught, because we just came off the previous semester. It was just a much cleaner version of fall 2020. Now, when I was talking about difficulty and Gitlet, I wanted to talk a little bit about the history of 61B over its entire lifetime. Now, this is not all the way up to date because the code I wrote to generate this beautiful figure doesn't work anymore, and I cannot get the libraries working. I tried regenerating it for 30 minutes today using modern data 100 type libraries, but I couldn't quite get it the way I wanted, so I'm just going to use the old one because I think it tells the same story. So in 2005, actually pre-2005, there was some situation. Then in the decade before I showed up, there was an interesting bistable pattern where Jonathan Chuchak would teach one semester. You may know him as also teaching 189, and then Paul Hildfinger would teach. And then Jonathan Chuchak would teach, and Paul Hildfinger would teach. And what you're seeing here is the difficulty as reported on the HKM survey at the end of the semester. So this level of difficulty is pretty high. Like this is, roughly on par with say 61C. And then this was the worthwhileness each semester, right? And so you can see that, it was, there was this long period where Paul and Jonathan were trading off. Jonathan had this I'm going to build data structures from scratch, and it's not going to be big projects. It's going to be a little more theory, and you're going to actually implement all the data structures. And there isn't like Gitlet or Build Your Own World or 2048 or those, or like Guitar Hero type things. It was like kind of nuts and bolts. We're going to build binary search trees and stuff like that. And then Paul Hildfinger was the polar extreme, which was we're not going to implement the data structures so much, but we're really going to build big projects. And so you have extreme selection bias in who is actually taking the class, because people would, flee Paul's class who didn't want to get clobbered by the projects, right? So then I showed up right around here. And so my first semester I was co-teaching with Paul. Over that time, I basically slowly tuned down the difficulty of 61B. We're right around this black line, even the present day. And that black line is the fall 1861A, just for some arbitrary reference point, okay? So I think the difficulty of the course is tuned about right. And then the worthwhileness, I don't actually show it, but it's actually climbed back up to where I was in the slightly more difficult days. And it's just an HKN survey, but I do watch this. And so I just want to let you know, like, I'm keenly aware of how things evolve over time and really trying to make sure that like I'm doing something that's really good for you. So this class is, tuning this difficulty is very hard. And I suspect that even though we've been at 4.0 the last 2 semesters not shown here, I think we're going to go up to a 4.1 or a 4.2 this semester because GitLab was harder. Okay. So on that note, I do want you guys to really think about what you want to be different, especially including difficulty as you fill out the survey. So what might change next time? I have a bunch of different possibilities up here. I mean, the big one is I don't think I want to run GitLab again. I know my TAs really like it. I know a lot of you like it, but I just feel like there's 2 problems. One, it's just not integrated with the course tightly enough. It's just not data structures enough. We have Build Your Own World to be the big open-ended thing where you talk about software engineering, and it doesn't have, it's just not as beautiful to me. Like Git is a piece of commodity software. It's cool to understand it. It's cool to build it, but it doesn't make my soul sing. Sorry. I still want to have a significant design component, which is why we brought GitLab back in. And we could do that by doing an open-ended version of the old Bare Maps project or the Spring 15 NordNet project, or it could be something else altogether. I could also maybe revise GitLab, but I mean, ultimately, I think, yeah, number one thing, it's too big. I think it's just too much of a toll on the bottom third or so of students in terms of your current programming skill. Now, that's not to say we couldn't have GitLab as like an optional thing, right? I can always include GitLab as a like a gold point or like some kind of bonus points thing, or as a 1-unit optional 61B adjunct course, like 61BG, which you can take if you want to do GitLab, right? And it would be pass, no pass or something. I could probably get that by the Committee on Course Instruction. So if those sort of things seem exciting to you, let me know. Every semester, I say I'd like to more proactively help students find community and study groups. And every semester, I don't quite do this, but I'm putting it on here so I could shame myself by looking at this and saying, why haven't you gotten that really working at? Hard to do, especially with coronavirus. I'd like to make Project 3 sharing easier. We did actually add the ability to run servers and let clients connect, but it was just a prototype this semester. Hopefully we can make that cooler and that could be a first-class feature of the project next time. I'm probably going to stick to having some online exams. I think there were some things about it I liked, and I maybe want to explore allowing students to actually run code. So one of the midterm 1 would be build something kind of like Dex, but you can write your own tests or whatever. You get 2 hours, and it'd be smaller than Dex because you can't do Dex in 2 hours. But a way to like demonstrate your skill in a more realistic environment. Maybe this is one of my weirder ideas: having weekly theory homework that ties in with the discussion closely. So the discussion actually talks about the homework, so that everything feels tightly integrated, and it hopefully keeps you on track. Maybe make Project 3 a multiplayer thing, and of course, crazy idea, lectures, discussions, and labs in person. And so let me know what else you might want to see on your post-final exam survey, and I will read it carefully. All right, I'm not going to answer those questions because I don't have time. Okay, and actually we also had a whole lecture about questions about course structure, so we don't need to do that. Okay. All right, so some closing thoughts. We're done, basically. I gotta say this. This job is so intense. I love it, and it drains me by the end of the semester, just as all your classes drain you. And I find it just, an absolutely gigantic responsibility. I say terrifying and awesome here, to decide how you spend your time at Berkeley, because I really do. Like when I decide to make a homework or a project that takes 10 hours, that's 10,000, 15,000 hours of human time that I've just allocated. Like that's a lot of time, just an enormous amount of effort. And so when I screw that up, I'm just wasting a bunch of people's time. And it's very precious, especially at Berkeley. Now, the reason I do this job as opposed to working at Google or whatever is because I really want, as I was saying, I feel like human dignity and flourishing should be like the thing that we focus on and actually try to encourage, right? And so I want you guys to lead more fulfilling lives in the future. And I feel like this class is a great way to do it because it really is the sweet spot to me. There's no other class I think I would enjoy teaching more, which is shocking because I didn't know any data structures 10 years ago. Really, truly. I learned data structures for my first job interviews in 2011 because I was an EE undergrad. And it's an amazing place in the world where the class is beautiful. It's very practical. It's the skill set you need in order to go get a job. It's very early in your lives when you're more malleable and you're kind of open to new experiences. And there's just so much you can do with it, right? I mean, it's just, yeah, great. And so, you know, I just feel incredibly privileged to teach at a school where I get one, an enormous number of students, two, like just an enormously diverse pool of students. And so that means I'm actually making a difference. And three, like you're just energetic and really go for it. It's really cool, you know? And so I hope I've done a good job. And I know, of course, 61B wasn't perfect. I'm well aware of the many flaws, and a lot of times they're just intractable trade-offs that you can't solve. And there's just some things I just don't have time to do, and TAs don't have time to do, or I'm negligent about sometimes. And sadly, it'll never be perfect, but you know, it's pretty good, I think. And so, you know, basically, I mean, thank you all for the emails or whatever else, or survey responses. I try and read as much as I can, for all the, you know, kind words, feedback, and understanding when things aren't as good as they could be. And I hope that, you know, this class, if not pivotal in your life, was at least a stepping stone to whatever super cool future you'll do. Okay, so very last thing I want to say is that 61B will need you, I guess, next fall. Sorry. Oops. So academic interning is the best way to, you know, give back. It's a way to learn more, help others, get some units, and maybe be a TA or tutor someday. So we'll have an announcement on our ed, and you can help out in the future, because this number will probably continue to grow next year. And even in 2 years, if this new declaration process comes to be, I bet 61B will remain gigantic. And so last, I of course need to thank my staff. They keep the wheels on this crazy on fire, out of control bus. These are my full-time GSAs, head TAs are in bold. I have my part-time GSIs. I have my tutors, the many academic interns out there. By the way, if you're in AI, you get to be memorialized on a slide like this someday, or immortalized. You know, thanks to everybody. Double thank you to Ada this semester for helping us as we, you know, this was a tough semester for everybody. And Ada was the front lines against so many people's life crises. And, you know, this class only functions because I have all of these people to help. You know, I got the total tally at the bottom. So it's been a fun and wild ride. I'll see you around. So we'll be doing those I'll randomly pick some people for a series of hanging out next week. I will try and do as many as I can. If we're close, I mean, if I can feasibly get a hangout with everybody, I'll try and do it just so you can actually meet me. I will also let you know whenever my random Twitch streaming career picks up, you know? So I had fun, and I'll see you guys in future classes. And with that, you know, the whole class disintegrates into nothingness. We have to do on final, I guess. And then we'll reconstitute ourselves next semester in entirely new environments. Cool. All right. I'm gonna look at everybody who's here. All right. Thanks, everybody. Bye. Okay. I'll stick around for 2 minutes if anybody has anything you want to jump to mind. Seem big.
Thank you.
Got it. Thank you. So interesting. Okay, now I know the demand for 195 is really high. I'm tired. These semesters end so intensely. All right. Yeah, come say hi in the fall. If you want to go about meeting me, there's a form. It should be on Ed. Yeah. Oh, that, right. Yeah, but someone was asking how do you do it. So fill out that form, Lucas, if you have it. Let's see how many responses there are, actually. I'll do that for you before we go. Might not sharing, am I sure? Okay, Ed, in person. How do I find this thing? Anybody have a link handy? This thing? Oh, the search is not working out for me here on Ed. Yeah, anybody who's remote, right? I mean, I'm happy to just come by office hours, you know? That sounds good. H195 is not open yet. It's just planned. Okay, so let's see. Form 61B. Where's this thing? Has anybody found the form? You know, the live Q&A, by the way, was basically my office hour substitute, Rohan. But yeah, there's a form to try and hang out on in person that I mentioned in some context somewhere. I juggled too many. I bet that's it. Yeah, that's the one. Okay, cool. Thank you for finding that. So if anybody wants to try and do the Glade Hangout, do it. Although actually probably not gonna do Memorial Glade now that I think about it. I think I need to, there's like rules about how many people I can have. 114. So can I do 10 hours of these next week? Maybe. It's possible. I'll try. Yeah. I'll need to relax though before then. I'm my 3-year-old has destroyed my sleep schedule this week. And the end of the semester is always a rush. Especially because I gotta finish writing that final. Don't do it. Daniel, don't drive 7 hours. I'll meet you in the fall. Unless you have no other opportunity, please don't travel that far to hang out awkwardly for an hour. Oh, nice. Oh yeah. I'm impressed that you did this class while having a 2-year-old, gotta say. Random person. I have so much respect for parents that I never had before having kids. Not that I disrespected parents, but now I get it. I really get it. Anyway, okay, cool. Right. Zachary's is great. It's very good. It's very good pizza. Okay. I'm gonna call it there. I gotta chill out before I have to go pick up my kid. See everybody.
Thank you. Take
Bye.
good care. Get some rest too.
Oh yeah.
So much.
Sure.
Bye.